So a little bit on the mechanics. The slides should already be up on SlideShare, and I tweeted them out, kind of an experiment. We'll see if everyone stays after they get to flip through the slides in 5 minutes. And hopefully we'll be talking a lot more about than what's just on the slides. If you need anything on all of this, just the Twitter hashtag is, or the Twitter username, Pat Meenan, is probably the easiest one to remember. And either follow or just ping me if you have any questions. I'm happy to respond, direct you to stuff, answer questions. It's also, the slides are on the Velocity site. Well, I uploaded them. There is usually a little bit of a lag before it gets attached to the session, but as soon as the Velocity team can get around to attaching it to the session, you'll be able to download the slides there. So don't worry about writing down anything that you see on the slides or anything like that. You should have full access to the slides. The video, they're recording as well. They're really good about dual licensing the video, so as soon as they give me access to the video, I'll publish it up on YouTube, so you'll be able to get it from there as well. I also have office hours in the exhibit hall, I believe, in the O'Reilly booth on Friday at 12:30. If you want some one-on-one time, you can schedule that, although I also encourage you not to wait. I'll be here the whole time. Just grab me in the hallways. The best part of Velocity Conference for me is the hallway conversations. The sessions are interesting, but you can sort of find all that stuff out. The one-on-one time with all the developers and the other browser teams and everything else is really what Velocity is about for me. So grab me. Don't hesitate to ask me questions. Talk about stuff. I love talking. So as Steve mentioned, primarily I split my time working on Chrome, on the Chrome team, and web page test. The two work really well together for me. I see slow stuff in the waterfalls and web page test all the time and go, wow, why is Chrome doing that? And so I get to go over and fix Chrome and go, okay, well, let's not do that anymore. You can also reach me. That's my web page test email address. Like I said, Twitter is, I'll usually have faster responses on Twitter, but I'll try and respond to everything. Service workers, I don't actually work on service workers. Let's just get that out of the way. I'm really excited about them. I think we can do really cool stuff with them. These are the guys that if you have anything really complicated you want to ask, or why did you do that, or just sort of want to thank someone, Alex Russell primarily works on the standards side of things, and Jake Archibald does a lot of the talks, demos, and the actual implementations with it. But they're the real experts. I'll pretend, I'll do my best up here. As far as mechanics go, we've got a small enough group. I'm a little blinded, but if you raise your hand at any point, if you have any questions, I'll try and get to it. I'll also pause as we're going along at hopefully opportune times between various sections, and we can discuss stuff. If no one asks any questions, you'll be in and out of here way too quickly, so please ask questions. Let's have some good discussions. A lot of what I'm going to be talking about are sort of, these are the things I thought would be cool that we can do with service workers and are actually doable, but they are by no means sort of the end-all, be-all of what can be done. And I'm expecting a lot of you guys here to come up with stuff that I couldn't even imagine. So jumping right in, service workers. What are they? So first, a little background. At least in Chrome, I wouldn't be surprised if a lot of the other browsers have very similar architectures. But this is how resources, images, JavaScript, the things that your page references get loaded. So you've got the DOM, which is the sort of the renderer, we call it, the main page in Chrome. It has its own in-memory cache. So if you have the same image referenced 10 times on a page, it's not going to go and try and fetch it 10 times. It'll just pull it from the memory cache, and it won't fetch those effectively. For things that it doesn't have in cache, it goes down to what it calls a resource fetcher, and that's sort of within the renderer side of Chrome, the thing that's responsible for getting all of the stuff that the browser doesn't have and that it needs, and deciding what order it should get them in. And then that kicks it over to the net stack, which actually does the fetching. But first, it checks its disk cache. So we also have an on-disk cache, and that's sort of the browser persistent cache. It checks it there, and then it goes and fetches it off of the network. Service workers go right in the middle, in between the net stack and the browser. And they basically get to inspect every single request that's going to go to the net stack, whether it's going to disk cache or it's going to the network. Let's see. So effectively, what you have is a man in the middle for your own pages. And you can do all sorts of cool things with that. So a couple of things that you can do. Well, what it lets you do, every request that's coming from your document, you have access to. You see visibility into cross-origin requests, requests to your own origin, and all of the headers. And you can manipulate them. You can create, you don't have to actually pass those requests through to the net stack. You can synthesize your own responses to all of those requests and make up random responses if you want for things that the browser's requesting for your page. I will say the cross-origin, I'll have a limitations slide in a second. It also has support for fetch, one of the newer ES6 capabilities, so you can also fetch resources from the resource worker. It doesn't have to be the same resource that was requested by the browser. So the browser can ask for Microsoft.com, and you can go off and fetch Apple.com if you want, if you own Microsoft.com and for some reason you'd want to do that. But there are sort of no restrictions on what you tell the browser based on what it asks for. It also has a few other APIs that it has access to. In particular, it has a programmable cache, so you can take care of querying for stuff in a cache without having to sort of do local storage hacks. And actually, local storage isn't supported. It only supports async APIs. So if you're using database storage for stuff, you need to use IndexedDB. Limitations. So we'll get this one right out of the way quickly. It's only for HTTPS documents. That's not conspiracy theory. Google wants HTTPS everywhere. Service workers, like I said, are a man in the middle for your page. The last thing you want to do is pick up a persistent man in the middle just because you happen to browse Wi-Fi on Starbucks somewhere. So you really want guarantees that whoever installed the service worker is actually the page the service worker belongs to. And we'll sort of get into, especially when we have some of the discussion, the scary things that service workers can do to pages. You really want those strong guarantees. So there's a really good reason it's HTTPS only. It's also not active for the first view of a page. So if you're hoping to improve the performance for your first views by doing crazy things in service workers, unfortunately, that's not possible. They need to install, the page needs to be able to describe the service worker, and then they get installed, and then they'll be activated for future navigations within whatever domain or scope you provide them. So they're great for things that don't have to happen on the first page load or the first visit. iframes. As far as the browser is concerned, iframes are separate documents. So this can be a limitation or a positive, but you do not have access to requests from other domains inside of iframes on your pages. So all of the social widgets that use iframes, the ads, that kind of stuff, you will not have access to. That does mean, however, that the people providing widgets and stuff can also implement service workers, like let's say the Google Plus button, for example, could build a service worker version of it that controls the iframe and gives all sorts of capabilities offline as well as other stuff for performance, totally containerized within the iframe. So it's kind of a double-edged sword. Push your partners. I'm really looking forward to see what a little looking forward to and scared to see what the ad companies can do with service workers in their iframes that they use. But offline ads is an exciting possibility as well. The CORS requests, you do see them if they are not allowing the cross-origin allow responses. If they're not allowing you to see their content, you can't see the contents of the responses. So the CORS protections are still in place, but you get to see the requests and the headers, and you can still synthesize responses. You just can't access the content of a fetch that goes to a cross-origin domain. So if you're hoping to rewrite Google Analytics, for example, and if it's not allowing CORS access, you won't be able to inspect the payload of the response and manipulate it. You can, however, still create your own response entirely and do whatever you want with it. There is no global state or concept of a page. The lifetime of service workers is going to be sort of one of the interesting challenges to work out. You see, once you get installed, you see requests flow through you. but you don't necessarily know, hey, this is a new navigation, or this is all part of this same navigation over here. I do believe, I'll have to check for sure, I do believe there's a client that gets attached to each request, so you can sort of separate out if there's multiple pages open at the same time, like multiple tabs. They'll all go through the same service worker, you'll see all the same requests coming through, but you can still disambiguate a little bit. But you don't sort of have lifetime, oh, this is during the page load, this is after, unless you bake the logic of knowing what those requests are in the service worker itself. And as I sort of mentioned earlier, there are no synchronous APIs. Everything is async only to prevent any blocking going on in the service workers. They are a man in the middle for all of your network requests. The last thing you want to do is have a blocking operation happen in there. And it's also sort of one of those best practices trying to unwind damage that we've done historically by introducing blocking APIs. So I think before I jump into any further, I'm going to start diving into actually how to use service workers next, but were there any questions on that part? Steve? So the question was a little more complicated than I can understand, but it was along the lines of iframes have a sandbox concept, and was it an attribute on the iframe or an attribute on the document that to prevent service workers?
Yeah, an attribute on the iframe. Like, I would just look up like this. I wondered if sandbox might restrict service workers. It doesn't mention it.
So would sandbox restrict service workers? I don't believe so, and I don't know. I mean, the service workers for a page have no access and no knowledge of the iframe anyway. The iframe is a completely separate document with its own service worker context. So I don't know that it makes, they're sandboxed by default, I guess is the easiest answer. If there are different domains, the service worker for the page doesn't even know the iframe requests exist, and it'll never see them. So you get it for free, although it also means you have, the one thing I don't know, and it's a little unfortunate, I haven't had a chance to experiment, is what happens with anonymous iframes. A lot of sort of the friendly iframes that can interact with pages, what's the domain for those, and what do the service worker capabilities look like for those? So that'll be an interesting experiment. And I'll say, so service workers, touch on it a little bit at the end, but they're available in stable on Chrome right now. They're available in stable, but they're not necessarily stable in stable. They're still very much a work in progress. A lot of the capabilities are there. Do not be surprised to find bugs, file bugs on crbug.com. Canary is certainly further along than stable, but they should be at the point where you can actually start using them and do useful things with them. So, I am a C++ programmer at heart. Your promises, your fetch, they confuse me. We'll see how this works. I've tried doing a whole bunch of stuff. I know enough JavaScript to be dangerous, and I do enough JavaScript to make a mess on web page test, basically, to get it to work. Hopefully, do not use my code examples as gospel. Use real developer code examples as gospel. Hopefully, this will just give you sort of the foundation, the information you need to go actually create something. I did test all this stuff, and it does work. I just can't guarantee it's the best or prettiest way to do any of this. So on your page, you need to register the service worker. And this is sort of why it doesn't work in first view cases. It needs to load the page and execute some JavaScript to tell the browser that there's going to be a service worker. That largely comes from navigator service worker.register. There's a little protection around it just to make sure it actually exists, make sure the browser supports service workers. You give it a path to the service worker JS, and you give it the scope that it's going to control for the domain. By default, the service workers will register for all of the requests for the fully qualified domain name. So if you're browsing www.google.com and you register a service worker on that, the service worker JS that you registered will be able to intercept requests for every page anywhere on the www.google.com domain. The scope lets you restrict it somewhat, and we've had some discussions offline that maybe the directory scoping isn't sufficient to restrict it the ways that you'd want, and that would be a good thing to provide feedback to the Chrome team on. But to restrict it so that, for example, www.google.com/news would be able to install a service worker that only affected anything under the news path of the google.com domain. When you've got sort of a large company with a bunch of different groups all touching the same domain, the last thing you want is, well, there's a lot of things you don't want, but you don't want fighting service workers for each other, but you also don't want someone to install a service worker not knowing anything about your app, and all of a sudden they're intercepting all of the requests for the pages that they had no idea even existed, and perhaps doing crazy things to them. Yes? So the question was, is there precedence if you register service workers at the root of the domain and at a subdirectory or a scope? Are they both active? That's a really good question. I haven't had a chance to test it. I'm assuming that they both register, and so the way service workers work, and we'll see in a second, they attach listeners to things, and my bet would be that they're both active. The interesting thing will be if you attach multiple service workers to the same scope, do they replace each other? And how do you sort of age out or kill a service worker? I haven't actually experimented with that, so that's a really good question. I don't have a good answer. I'll experiment with it some afterwards and tweet it out if I can figure it out. All right. So as far as the page goes, that's all of the code you need to drop on a page to get a service worker activated. So sort of suffering from the just drop this piece of JavaScript on your page and you'll get all sorts of magic symptoms, but you don't necessarily have to have everyone aware of how to build service workers and do everything. You can provide like the apps. If you have a large company and you've got sort of the foundation, this is the company's service worker, thou shalt use it. Just add this snippet of JavaScript to your page, kind of a thing. The service worker JS itself, there are a couple of things that it needs to do to actually install and become active. Well, it gets a couple of hook points where it can do things. Those are the installation, the first time it's downloaded, and the activated, which is when it's started up. And then it also, okay. And you can also tell it not to complete, so it's all promises based, and you don't want to complete until you've done all of the offline activities you want to do. So you can do really expensive stuff at install time. You can fetch a whole bunch of resources to pre-cache them, or you can just go, okay, whatever, I'm here, thank you. And then it won't go on to the activation phase until the install is complete. And then you can also attach a listener to the activation that'll let you know when it got started up and when it's actually running. The really interesting thing, for me anyway, is the listener that you can attach to fetch events. And this is where all of the real work happens in the service worker. And what you get past is you get past a fetch event for every request that we talked about that's going to go through the service worker. And then you can respond with whatever you would like. You need to respond with a response. It's a standard ES6 fetch object. You can create your own. This would be a really bad idea for a service worker to respond with hello world for every single network request because your pages would be completely busted at that point. In case it wasn't clear, you also intercept all of the navigations for the main documents on the domain that you register for. Every network request once a service worker is registered. So if you register a google.com service worker, for example, your next navigation to a search or a news page or whatever, the HTML for that page will also go through the service worker and be intercepted. So all of a sudden now all of Google's search results or search pages look like hello world. So that is the fundamentals, and on how you install a service worker. I'm going to go through, I'll get a question in just a second. Next up is going to be the mechanics of an example of installing an offline service worker and some of the stuff you can do. And then we'll dive into what I think is the really interesting bits. There was a question right there? So the question was, what happens if and when you screw up and you have a service worker registered for the entire domain that is now broken, and is there an emergency way to recover that? So there's a couple of paths. The user-facing version is control refresh will bypass the service worker and refetch the page, and that'll cause everything to re-download. But unfortunately, that's user-facing. The cache times on the service worker, regardless of how long you set the cache time for, it will always check for an updated service worker every 24 hours, I believe. But that does mean your site will be busted for 24 hours. I was talking with some people this morning that wanted me to drive home the point of you need really good tests on your service workers because the amount of damage that they can do is unprecedented. In the grand scheme of hand developers a gun and shoot themselves in the foot, this is like a giant cannon. So you can do really cool things with them. You can also do incredible amounts of damage with them. Things like a JavaScript exception in your service worker happening at the wrong time may break all fetches for your domain, right? So I have a feeling we're going to have a lot of learning going on around service workers and maybe recovery paths and stuff like that. The question was, what is the lifespan of the service worker? When does it get reset? It doesn't really get reset per se, as long as, so you have an expires time on the JS for the service worker. Effectively, that's the lifetime of it. It will automatically check for new versions of it regardless of the expires every 24 hours. So you can use that as a, hey, I want to try this out for a day or an hour or whatever and expire it and not use the service worker anymore. There's also an unregister. I'm fairly sure there's an unregister where you can actively remove the service worker if you want using JavaScript. The lifetime of the service worker itself, while it's running, you can't always be guaranteed that the service worker is going to be alive while your page is loading or loaded. It sort of has its own lifetime. It can come and go as it wants. It may even be running when your page isn't running at times to do background activities. So it kind of has its own running lifespan as well. Alrighty. So one of the big use cases that gets talked a lot about is offline, on using service workers to create offline apps and try and make them sort of more appy. This works really well if your app is actually expecting service workers, or if it's a single page app where you sort of have the shell HTML and JavaScript, the application logic is there, and all of the UI is rendered in JS based on network fetches. Mostly because if you sort of think about service workers being able to intercept network fetches and synthesize responses, you need to be able to synthesize the offline content. And doing that for all of the HTML becomes somewhat more difficult. So it becomes, I'd say, a progressive enhancement for single-page apps for doing offline support. And the main way you can pre-cache offline content, stuff that you want to be available for offline, or even if it's just a, sorry, you're not online right now kind of page. Although, for the most part, if you have like landing pages and certain main navigation points, caching the offline content for those is fairly easy, and you can always respond with those, and the user will at least be able to do some offline interaction with your app completely transparently, without having to like completely rebuild your app, assuming it's sort of built in the single-page app model. If you're doing it with a full-blown HTML app, or not even app, just an HTML page, the offline experience becomes a little more complicated, and it's up to you to, all you see really is the network request. That's the HTML level. It's sort of up to you to figure out what's a good experience to deliver to the users at that level. What content do you want to show them? But it basically becomes a case of, hey, am I online? If so, pass the network requests through. If I'm not online, well, actually, when you're online, pass the network requests through and cache the responses so you still have them available locally. If I'm not online, do I have the cached version available? If so, serve that. If not, generate a response to the request that's appropriate for offline navigation, even if it's just a sorry, you're offline right now error message. Although delivering as complete as an experience as possible is probably the best user experience. So fundamentally, how that would look in a service worker. So first we do the installation, and we want to block the installation until, and this is what the caches API looks like. You give it a named cache for the cache, not for the individual objects in this case. And this is sort of where my promises in expertise comes in. The then chains drive me insane. But so then after the cache is open, what you'll do is it provides, the cache has an easy API effectively that you can give it just the paths to a bunch of resources, and it will go ahead and take care of the fetching for you. So you say, okay, these are all the things I want you to cache, and that will complete only after all of those resources have been fetched. So at the end of this whole giant promise chain, the install will not complete until all of the resources that you've told the cache have been fetched and fed into your offline cache. This offline cache is different than the browser cache in that this is one that you control, and it's yours and fully programmable. It is separate in that the actual disk cache for the browser, at least currently, is implemented. I don't think we do any deduping. You sort of have two levels of caching effectively at that point. The network stack will cache its own fetch requests, and then you'll have your own programmed version of the cache where you can do whatever you want with the resources. And that's largely because people were hacking their own on top of local storage anyway. This is just a sort of much better interface for doing that and much more performant as well. Yes?
So that means you have to do all of your own cache management. You have to expire things out of it. You have to manage space.
So the question was, that means you have to do all of your own cache management, expiring, managing space. Also a very good question. I'm fairly certain that you do. As far as expiring, I believe it will still honor expires, or it'll give you information about things being expired, but you don't have to honor if you want to follow that. Things actually getting deleted out of the cache, yes, you have to do that yourself. I also don't believe there's a size limit on the cache currently, which also won't be a thing that lasts very long if it gets abused. So, like I said, service workers are unstable but aren't necessarily stable in themselves, in that it's sort of an evolving, as people use them and as people bump into issues or have questions, restrictions and or capabilities will be added. But for right now, yes, there are a bunch of metadata attributes that get attached to all of them. You get all the headers and everything else for all of the stuff that gets stored in cache, and you have full programmatic access to all of that when you query the cache. It also won't refresh itself automatically. That's up to you to manage as well. There's a question right here.
So Pat, you mentioned that when you add to the cache that it will do its own requests and responses to fill the cache. So that happens outside of any sort of normal browser requests?
Yes. So the question was, when you instruct the cache to populate with these resources, it does its own fetching, and that happens completely independently of any sort of browser fetch requests. Yes, all you told the browser to do was install a service worker. Your service worker at install time can do whatever it wants. It's its own, it's running its own worker, web worker effectively. and it runs at install time. You can fetch anything you want, do anything you want, completely independent of the page that was instructing you to install.
So are you going to talk about debugging, or does the Chrome, any of the Chrome development tools allow you to figure out what's going on during all this process?
So the question was, am I going to talk about debugging? I wasn't going to, but I can talk about it now. So the dev tools, there's a Chrome / service workers internals, and I think there's also just a service workers that lets you set a breakpoint to stop in the Chrome dev tools at the moment that the service worker starts up. So all of the Chrome dev tools at that point work and can inspect and debug and do whatever you want with service workers. So yes, you can step through them. The main thing is you just need to go in there and turn on the checkbox that says start debugging the service workers. And that will be your friend because you'll spend a fair amount of time. That's the only reason I even got any of these examples working, was being able to step through them and go, oh, hey, I'm missing a semicolon, or that one doesn't need a semicolon there, and that kind of stuff. Yeah, so my code wouldn't even load the first 3 or 4 times I tried. That's why I like compiled languages, but that's just me. And yes, I totally depend on the compiler telling me when I have typos. So once you're installed, this is sort of, for me, the exciting parts. When you install the fetch handler, every request is going to go through here. So this is kind of, I imagine, sort of like the old Windows main message loop switch statements. It's going to be a switch that's like this long for, does the request look like this? Does the request look like this? Do this. But in this case, all we're going to do is we're going to check and see if you're online. So it does have access to the navigator interface for online, offline status. And if we're online, what we're going to do, well, it wouldn't fit on a slide, so I bumped it out into a separate function. We're going to do an online version of the request and pass the request. So the event that comes in to the event listener, it has a whole bunch of attributes about who initiated the request, so you can tell which client it came from and stuff like that. Is the event, it's a normal JavaScript event, so it's got sort of is bubbleable and all that kind of stuff. The real key inside of there is the request, which is an ES6 fetch request, which has all of the headers, the URL, and that kind of stuff. So we're going to pass that through to our online request function. And if we're offline, we're going to pass that through to the offline request function. So in the case of an online request, what we're going to do is, okay, first thing we're going to do is we're going to check the cache and see if we already have a cached version of the request, because we don't necessarily need to go out to the network for every single request. Honestly, I probably should have put this outside of the online request code and always just check the cache, regardless of our online-offline state in the main fetch handler. Exercise left to the implementer. And then, okay, and so the caches, they have a match API where you can pass it a path and it'll do a substring match on that path to try and find the request in the cache. Or you can pass, need to look at the actual API. I think you can do all sorts of crazy regex stuff with the match API as well for searching through your offline cache. In this case, we're looking for an exact match for the request. Do we have an exact match for what they were asking for? And then the event handler or the promise handler for the match gets a response object passed to it. If the response exists, that means it found it in the cache, and we just return that response. If it doesn't exist, well, then it wasn't in the cache, and we go ahead and we pass through to a normal fetch. And this is sort of the ES6 fetch, and that will return a response. So all we're doing in this case is really doing, do we have it in cache? If not, fetch it from the network. This is sort of the normal online use case of passing all of the requests through. And this is what your pass-through logic will usually end up looking like. And you can probably even skip the local cache matching if you want to just rely on the browser cache, because the fetch is going to still go through the network stack and go into the browser's offline cache before it does anything on the actual network. The offline, oh, sorry, this is, oh, we're still working in the online case. Yeah, so this is actually inside of that. Instead of just doing a fetch, what we really want to do, I think I probably forgot to delete that slide when I realized my case was too simple. So all of the ES6 requests and responses are streams, which means they can only be processed once. So if you want to actually do anything with the content of the request or response payload, not sort of the metadata, what's the URL, that kind of stuff, you need to clone them. Otherwise, you're going to sort of burn your one-time chance at reading the data. So in this case, what we're going to do is we're going to clone the request that we want to send out on the network. The main reason we want to do that is we want to access the request itself for populating the cache as well. And then we go ahead and do the fetch request and look for the response. When the response comes back, we're going to want to do something with the response, so we also need to clone it. So now we've got 2 copies of the request and the response. And then we open the cache. Here we're going to have a sort of a definition for the cache name rather than just sort of copying and versioning the cache name everywhere. We open the cache, we wait for the cache to open, and then we put the response that we got back over the network along with the request into the cache. So this is the one time where we're burning, this is the second time. So when we did the fetch, we burned one of the requests, and now when we're putting things in the cache, it needs to be able to inspect the request payload as well, which is why we needed to clone it. It's also caching the response data that we also need to send to the browser, which is why we had to clone it there. And then we also return the original version of the response for the browser to go ahead and do its processing on. So the pass-through ends up being, it won't fit on a slide, but it ends up being a fairly involved caching of the live network requests so that we have them for future requests as offline access. In the offline case, it ends up being somewhat shorter. In this case, I'm only doing, yeah, so like I said, you can do regex matches. Oh, in this case, I'm just doing a regex match on the URL saying, hey, if it's a PNG and we're offline, I want to match the offline PNG that I cached earlier when I did the install. This is the one image I'm going to use as the placeholder when we're offline for everything. You can obviously do exact matches and go, hey, did I have the exact match in cache first? If not, use a placeholder image. You can have multiple placeholder images depending on the type of, it all has to be, all you really have access to is the URL. So you have to describe sort of the context or know where in the page it's going to be if you want to use different placeholders and stuff like that. Question? So getting confused with caches. Is this the service worker cache or the browser cache? Anything I talk about in my talk here is all service worker cache. This is the cache that you have programmatic access to, but it's also only the things you explicitly put into it. So when I do the caches match here for the offline PNG, it's the ones that I installed at service worker install time in the cache that I control. It's not, hey, browser, do you happen to have this offline PNG image somewhere in your network cache? Can I make that request? The only way you can make that request is to do a fetch request for the offline PNG and see if you get a response. The response, if you're online, it'll go out to the network if it's a cache miss. If you're offline and it's in the browser's cache, you'll still get the response. You can't do sort of a, hey, browser's cache, do you happen to have this in your cache, but please don't go hit the network if you're online. That's the sort of the one use case that you can't do. Yes?
Aside from managing the cache, is there, let's say you have 2 pages, one with service worker, one without. Is there a better, from performance perspective, which is better? Does service worker give you better performance if it's not only the same thing?
So the question was, aside from managing the cache, if you have two pages, one with service worker, one without, does the service worker provide any performance benefits? Not unless you're doing something intelligent in the service worker. It's another step in the network request, so if anything, it's always going to be slightly slower, slightly being measured in hopefully small numbers of milliseconds, because it needs to route every request through the JavaScript in the service worker before it actually does anything useful with them. The presumption is that the service workers will be doing useful things with the network requests that actually make the pages faster. And that's some of the stuff that I'm going to be talking about, hopefully, once we get right out of offline. But also, being able to deliver an offline experience can be a lot faster as well.
Does all these caching create overhead when the user is actually browsing the site online? And if it does it have any kind of significant impact on performance?
So does all of this caching provide any performance overhead while the user's browsing online? Depends on what you're doing with the caches. Like I said, everything's async. It may. I mean, the one case that I can see sort of being problematic is if you cascade things in such a way that you save the HTML locally in your own programmable cache, and you wait until that completes before you return it to the browser, you won't get sort of the streaming performance with chunking, for example. Chunking is sort of the one interesting use case that I'm not sure how it'll interact with, where usually the browser can process the HTML response as it's streaming in. You can do that with the cache. I'm not sure how the promises work if you chain them in such a way that you have to wait until you fully write the HTML into the local cache before you respond. I'm pretty sure the way it works is it won't add any overhead. And the way the promises and the cache entries work is they'll get created based on the streams that you give them, but they won't wait until the stream is complete before the promise completes. So you can hand the cache the fetch response object, if you would, and it'll create the metadata, which is all in memory. It doesn't have to hit disk for that. And it'll create the entry for it, and as the stream comes in, it'll start populating it, but it won't wait until that finishes and you can pass things back to the browser. Although that's an interesting use case to experiment with. I'd expect minimal overhead, if any, just because a lot of the metadata for the cache management is all in RAM. And we do it at least in Chrome, we do it at the net, on the net side of things anyway. And a cache hit's going to be way fast. Well, I'd say a cache hit's going to be way faster than a miss and hit the network. Depends on networking conditions. Disks can be slow and networks can be fast. And when those two come together, sometimes the network's actually a lot faster than the disk cache. Your mileage may vary. Provide feedback. That's the best. If you see any slow points, definitely if you see any problems where it is adding overhead, file a bug, because that's definitely not the intent. And that's the reason only async APIs are supported, is to try and eliminate as much overhead and opportunity for overhead as possible. Okay. Everyone still with me? All right. And in this case, if we're looking for an HTML page and we're offline, we'll have an offline placeholder HTML. Yes?
Question about lifecycle. As far as like you're sending off a request, you're on a page, you navigate off of that page, is the request service worker still running in the background?
So the question was, as far as lifecycle goes, you're on a page, it fires off a request, the service worker's doing its own thing, you navigate away, is that still running in the background? Yes. Service workers have their own lifetime. They are not bound to a page or any set of pages at all. So you can even schedule and do all sorts of other offline activities even beyond when that fetch response comes back, which also causes interesting side effects if you start doing too much. And so I don't guarantee that the browser won't kill you out of spite, but hopefully it won't. And that's probably one of the areas where if we see like every page on the planet doing service workers and all of them running timers in the background to try and sync all sorts of offline activity, I expect you'll start to see the knobs turning and restrictions getting put in place. But early on, it's kind of free reign. What if the browser is closed? If the browser is really closed, then it's gone, right? I don't know if you've tried closing Chrome at any point recently. It may not be gone when the window is gone, because there's the background notifications support. There's a whole lot of stuff, even on desktop Chrome, where it stays running in the background even after you close the browser. And the same thing happens on Android as well for background notifications and stuff like that. So if you really close it and you tell it, no, don't allow Chrome to run in the background, and you close the browser, the service workers are gone as well. Yes?
Another question, can you do like invasive things like open up the browser, run in the background, or open up a new tab, and things like that?
So the question was, can you do invasive things like open up the browser in the background or open up a new tab? The service workers have no access to tabs, and they have no access to UI or DOMs or anything like that. They can burn CPU in the background and burn network and do a whole bunch of things under the covers like that, but you won't be popping up adware at random times in the background, for example, if that was either a hope or a concern. Okay, so I think this is where, yes, so this is where I start to get really excited, and the main reason I propose this talk is most of the discussions around service worker are sort of the offline capabilities, and particularly around single page apps, and I think that's a lot of we can do a lot of things that apps do in the web and trying to push that model forward. But to me, being sort of a network geek and always sitting in the network path, having a JavaScript programmable man in the middle for all of my pages is just like freaking awesome. You can do all sorts of really cool things with them. Cool things that people have been asking the browsers to do forever, but have either never been implemented or is too much of a use case. And so I wanted to talk about sort of some of the ideas I had to get you guys thinking about some of the cool stuff that you can build, and you guys go off and build all sorts of cool stuff. So one of the cool things that you can do, custom error pages. So you're not restricted if you're offline, for example, or you get a DNS error. You don't necessarily, when you have a service worker in the path, you don't have to tell the browser that it was offline, right? You can pass back your own custom error page that has its own error messaging, does its own retries, does whatever you want. DNS failures, for example. If you have a CDN issue where it's getting like a 502 because it can't go back to the origin, rather than returning the CDN error page, you can return your own error page that goes, hey, it looks like my crappy CDN is offline right now, or my site's offline, CDN's doing great, or whatever it is. Hang on a second, I'm going to keep retrying. Or you can have a game or do whatever you want. You don't have to do whatever the browser provides you. I think that was it. So yeah, and that's a fairly easy use case where if you see it looks like it's a base page request, an HTML request, pass it through, do the fetch request, look at the response. If it's not a 200 response, generate your own response that you want to send back to the browser with your own UI. I also encourage you to be careful doing this in that you may confuse users with too much custom UI. But in the grand scheme of cool things you can do, this is one of them. If you all have your own custom, you may be offline error pages, the users may not know what to do. So interesting use case for that would be logging back to the servers. You post back from the service worker. Yes, you can totally do that. You read my mind. That's one of these slides coming up. So SPOFs, single point of failure, is sort of near and dear to my heart. If you're not aware, on web page tests, I do a lot of SPOF emulation, so you can see what does it look like when the social widget's offline, what does it do to my page. You can see sort of the side-by-side videos where you're staring at a blank page for 20 seconds because the ad system or the Facebook widget, well, they're really good about it now, but back in the day, if the JavaScript was offline, the page wouldn't render at all. Also Spotfomatic, a Chrome extension that lets you see and detect those as you're navigating around. But what you can do with your service worker is inspect every network request that's coming through. When the request comes through, set a timer and initiate the fetch. And if it's to a third-party domain and the fetch doesn't respond within, say, 3 seconds or whatever, time out and return an error. And all of a sudden, the browser just fails over and continues as if it failed, but you can have your own custom timeouts. You can go, okay, this is an ad. I care about this. I want my money. Okay, any ad requests, we'll give them 10 seconds or whatever. Oh, this is a social widget. You know, they're great for my SEO or my bringing traffic into my site, but I don't really care if they're there. So set a timeout, say 1 second for Google Plus button, JS or whatever, any of those. And so you can build your own layer in the networking stack that prevents these single point of failures from affecting any of your pages with your own custom timeout logic. And it's a really simple filter that just passes everything through. If it's not a known domain that you care about, apply your own timeout to the fetch requests and return error responses back. Question? Are there any limitations on concurrent connections? So the service workers, where they sit in the stack is way, way, way above the point where concurrent connection limits are decided. And so the fetches that they initiate will still be subject to normal network contention decisions by Chrome. So if you're on, well, these are all SSL, but if you're on HTTP2, they'll all go over the same channel anyway. But yes, you'll have no more than 6 connections to a host at a time, but it'll take care of coalescing those and issuing those in the right order for you and complete. So you won't sort of get a, sorry, you can't issue that request right now. It'll just take, if you issue 100 fetch requests and they're all pending still, the network stack will take care of scheduling them in such a way that for the most part, they'll be first come, first serve and just go through them based on however many connections it has available. As far as priorities go, I think the fetch lets you tell it what kind of content you're requesting. If not, that's going to be an interesting area if you're competing with JavaScript coming from the browser, for example, because the network stack has its own sort of prioritization based on the type of content it thinks it's fetching. So it's not entirely a FIFO queue. There's a question behind. Do you need course headers for third-party JavaScript? To inspect the third-party JavaScript, you need course headers. However, you still see every single fetch request for the third-party JavaScript. So you can still do the timeouts and everything else. You can see if they complete, when they complete. So you don't need to have course headers to be able to prevent the SPOFs, only if you actually wanted to manipulate the contents of the response coming from the third party. But you can still synthesize your own responses for the third-party content. And in this case, it might just be an error or a placeholder JavaScript that does nothing or whatever. Follow-up.
Yeah, another question. So, in the previous slide, you talked about catching errors and doing something else to the user. What kind of errors can you catch with service workers? You gave an example of DNS failure, but how to take DNS failures with permission.
So the question was, what kind of errors can you catch using the service workers? My example being DNS errors. So I'm not entirely sure what the, so if you're initiating fetches, right, ES6 fetches, they'll either succeed or they won't. The granularity into your visibility of why they failed, I'm not entirely sure what we expose to you. If you get, like this was a 502 versus a DNS failure, if that's not exposed, provide feedback to the fetch spec guys and ask that it get added, because there's not really any privacy information or reasons for not having it there. I I'd be surprised if you didn't get some level of error code information to the fetch. The metadata on the response object should give you an error code or a response code. I just don't know what it looks like in the case of a DNS failure. That will say you will still detect DNS failures. You may just not know that it was a DNS failure or why it failed. You'll still catch the failures, though. We're still doing pretty good on time. Another exciting possibility for me, CDN Origin Failovers. So if your CDN is having issues, I see this fairly frequently. Well, I've had really good luck with my CDNs, but every now and then I get one edge node, like the Amsterdam edge node every now and then for some reason is problematic for me. And I'll get users that are complaining, hey, web page test is down, when it's really just a stuck issue on one of the edge nodes somewhere and not something that I have access to. Or I don't want to turn off the entire CDN, which provides enormous offload capabilities, just because one edge node's having issues. So one of the things you can do with the service workers is you can inspect every request that's coming through and go, hey, this is one of my known CDNs. Set a timeout, either a timeout or even just on error conditions. Go, hey, the request from the CDN failed. Maybe I should try it from the origin instead. And just pass it straight through to the origin or to another CDN to see if you can fulfill it. So you can sort of start doing your own failover logic entirely within the service worker layer for doing some of that kind of stuff. And you can actually race them. So when you set the timeout, you can go, okay, I'm going to try and fetch things from my CDN, but if they don't come back within 2 seconds or so, I'll try fetching them from the origin, but I won't cancel the fetch on the CDN just in case that one completes sooner anyway. And you can sort of start racing them. You don't necessarily want to race them all the time because you'll be doubling the data for the user, but you'll also be doubling the load on your stuff. And sort of another flavor of that is MultiCDN optimizations. These you usually end up being seen done at the DNS layer. There's a whole bunch of companies, I'm sure they'll be in the exhibit hall as well, that provide multi-CDN offerings at the DNS level where it'll pick the fastest CDN for your users for you. You can build all that kind of cool stuff into service workers now as well. You can, as the requests come through, look at the domain that it's coming from. Is it one of your CDN domains? And if so, you can route it to whichever CDN you want. And you can do it for that individual user. You can do testing, right? You can go, okay, 50% of the time until I learn what works best for this user, I'm going to route requests to CDN 1 and CDN 2. And I'm going to measure and see which one performs best for this user. And then maybe make that stickier and go, okay, the faster one, I'll make requests to that 99% of the time. And keep some small fallback so you're still measuring the other CDN in case the user's mobile or whatever. But you can start doing stuff entirely in your own application logic for testing at an individual user level and not relying on the DNS level anymore, routing that user to the fastest CDN. Have a small bullet at the end. You could even, in theory, race the CDNs in parallel. And every request that comes down, issue 2 requests out to both CDNs and see which one comes back faster. I wouldn't encourage doing that a lot just because you're doubling the requests and you're doubling the bill you pay to the CDN and stuff, but it's, you know, giant cannon foot. Have fun. Yes? How does service worker interact with resource timing? Yes. That's a pain point right now. They completely break resource timing. And that's something that Ilya is actually working on the spec. I think it was just added to the spec to add a worker time component to the resource timings and allow for, if the fetch requests actually ended up passing through to the network stack, still providing the resource timing of the original fetch as well as any processing time that happened due to service workers. But if it's entirely synthesized from service workers, you won't have the network times, you'll just have the worker times. The service workers themselves have access or should have access to the resource timings for the requests they initiate. But from the page level, things start to get a little honky. And yes, I expect that to be a continuing point of learning as people start rolling out more with service workers. Yes?
Maybe see the log, or when you're debugging it, I don't know if you're gonna get into that, but seeing what's happening with service workers, how many are running in your browser.
So the question was, is there going to be a way to see the log sort of for debugging purposes, how many service workers are running and stuff like that? Yes, the service workers internals page will list all of the running service workers. So you can see what's running. You can step into them. You can debug them. You can do the dev tools in Chrome all fully work with the service workers, which is convenient because the DevRel guys use those a lot. So whenever they're working with examples, they spend almost all their time inside of the Chrome dev tools. Oh, right there. So service workers interacting with server push. So the service worker initiates a fetch request. The server does a whole bunch of server push stuff. What happens in that case? The stuff that the server is pushing down in server push, the service worker will never see. Those are just going to get put into the network cache. Pretty much the same way as if a request came from a page and the server started pushing a whole bunch of resources. Those go in the next layer cache in the network disk cache, so that if and when they get requested at some point in the future, it'll be able to be returned, but the service worker has no visibility into the push from HTTP2. All right, stale well revalidate. Anyone familiar with that spec? It's been sort of going around. I don't know. It hasn't actually made it to implementation yet, but it's one that I'm sort of really excited about. And what that is you can, for JavaScript, so things that have, you can't version the resource, like Google Analytics JavaScript or the Facebook widget JavaScript that everyone codes into their pages and have a fixed URL. Usually those will have a short cache lifetime, both in case of emergency or just so that they can do frequent updates. And the stale well revalidate is a way of telling the browser, you're allowed to use this resource for up to 2 hours beyond the expires date. Just in parallel, go and check and see if there's a fresher version. So that prevents, once a resource is expired, the browser doesn't have to automatically go hit the network right away. It can return with the version it has in cache while in the background doing an update check to see if it has a newer version of it. The cool thing with service workers is you can implement this entirely on your own without the browser having to do anything. Since you have your own programmable cache, you can respond with the cached resource and then initiate a fetch request to see if there's a newer version available and update your cache based on whatever logic you want. And not only for your resources, you can do it for the third-party course content as well. Also, works best if you know what resources you're doing this to, and you can also do this for resources like the Google Analytics script. Even if Google doesn't put stale while revalidate headers on their resources, it's your logic. You can decide how long you want to use a stale Google Analytics script on your pages while in the background checking for an updated version. And since the way the caches work, so you've got your own micro cache, right? So your version of Google Analytics will be whatever Google Analytics was the last time someone visited one of your pages in your cache, not necessarily the time someone visited any other page that happened to include the Google Analytics JS. But since the caches are sort of cascaded, when you go to refresh it, you'll be pulling from the network cache, the disk cache browser-wide, and then only if it's actually expired will it go out and hit the network. And that's all sort of in your refresh. So, question?
So I've been looking at this for optimizing beacons that you just want to send a ping to the server, but you don't really care if it sends the 1 pixel GIF or whatever you're coming back. So would this be able to also send all the header information that goes along with that request through
So the question was, he's been experimenting with using it for beacons, and can you reproduce all of the headers on the fetch request? Yeah, so I encourage you, just hack up a really simple service worker and step into DevTools and inspect the request object. You have visibility into all of the headers, and you can reproduce all of the headers, either on what you pass through or even just if you're synthesizing your own fetch request, you can duplicate all the headers. But when you pass it through, it passes all of the headers through as the browser requested them, and you can see all of the headers as well and do whatever you want. You can add your own headers to them as well, and you see all of the headers on the response objects as well, which is sort of one of the cool things that you don't normally get visibility into. Although if you're using it for beacons, I also encourage looking at the beacon API. It's like 6 of one, half a dozen of another. You can implement your own version of the beacon API with service workers and do your own guarantees on delivery and everything else. Which one's going to be supported first in all of the browsers? Really good question. I think Beacon is probably further along in that I'm fairly certain Chrome, Firefox, and IE all support Beacon. I think IE does. And only Chrome, well, and Opera at this point, I largely lump in with Chrome because they are effectively the same at the upper levels anyway. And service workers, Chrome and Firefox, I don't know sort of IE what the plans are, and Safari is kind of anyone's best guess in all cases. But they're doing good. They're coming along. I expect adoption and interest will drive everything, right? Same thing kind of happened with HTTP2. As proof is in the pudding and it provides real benefits and people are getting real uses out of it, the more people that use it, the faster the browsers will adopt. And hopping on early also lets you sort of define how they work, primarily by providing feedback into the Chrome team of, hey, these are my pain points, this doesn't work well for my use case. Things like the scope, for example, works great if all of your URLs are set up in such a way that you do have separate directory structures, but I'd rather have a regex or some other way of providing scope. So sort of a lot of those things, providing feedback into the Chrome team, the earlier, or even into just the standards body process for the service workers and fetch. The earlier you get involved, the more likely you are to actually be able to steer the spec in a way that makes it useful for you. Prefetching. So one of the use cases here is you have access to all of the response headers from the server. The server is more than welcome to attach custom response headers that are hints of resources that the browser is probably going to need for this page. The service worker can see those as it's coming through and start initiating background requests for those other resources before the browser even asks for them. So you can build your own prefetch logic entirely in service workers as well. And you can decide, do you do them actively now? Are they going to be like needed for the current page? Do I have some form of idle prefetch where I start downloading stuff only when I'm idle, like based on some timer or no other requests going on, stuff like that. That was almost sad to make a slide since it's 2 bullets. This is where things start getting hairy. So you could build your own resource prioritization and scheduler entirely in service workers if you're not happy with the order that the browser fetches things in, right? So the browser will make its requests into you as it discovers resources, as the preloader scanner finds them, as the main styles get applied, it finds fonts and whatever. They all come into you, and it's up to you to do with that what you want. You don't necessarily have to act on any of those right away. You can go, hey, I know Chrome really sucks about downloading all of my late body JavaScript right at the beginning of the head of the document. I wish it wouldn't do that. I agree with you, working on it. But in the meantime, you could go, hey, I know these scripts are all late body scripts. I really don't want to download these right when the browser requests them. I want to wait until I've had a chance to fetch just the critical resources and maybe a couple of above the fold images, and then I want to issue those requests. You can make all that scheduling logic completely in the service worker and hold on to those requests and only issue them at the point that you decide you want them to go through. Same thing you can do for like late body images. You can delay load them whenever you want. Things going across multiple domains. Maybe you don't want the Facebook stuff to run all at the beginning or while your critical stuff is running. And you can do sort of fine-grained cross-domain scheduling that the browser maybe isn't doing the best decisions for your pages. Also be careful because you can shoot yourself in the foot in multiple situations, but yeah, especially if you're holding off JavaScript and like never issue it and the page never renders, or you need to be sure you're scheduling and aware of the individual pages that are loading and you don't all of a sudden start cross-scheduling resources that come in from multiple page requests against each other and stuff like that. But in the grand scheme of really cool, awesome possibilities and power, this is really high up on my list. Also really complicated to implement well. But. Delta compression. Near and dear to my heart. So anyone play with SDCH much? Yeah, not many. Generating dictionaries. So those that aren't familiar, SDCH is a delta compression that Chrome supports where you can reference a dictionary and say, hey, pages on this domain will use this dictionary as an optional compression mechanism on top of gzip. And so when Chrome advertises and says, hey, I have this dictionary downloaded locally, you can respond with a delta compressed version of the pages. Unfortunately, it's sort of that one algorithm. The number of dictionaries you can support is very limited. It's largely one dictionary per domain or scope kind of area. And generating intelligent dictionaries is difficult at best. With service workers, you can build your own delta compression that does whatever you want. So for me, for web page test, one of the things that I do is all of my JavaScript gets really dumb versioning. I add a query param with v equals 2, v equals 3 for what the version is. So the service worker can look at the query param, and when it does the cache check, it can see, hey, do I have any version of this URL? Yes, I have the current one. Okay, send the one they're asking for, send it back. No, I have like version 2, but they asked for version 3. Okay, well, I'll make a fetch request to the server that says, hey, give me the delta between version 2 and version 3 of this JS file. And then the server can send down just the patch difference between those two. I can apply the patch locally to the version 2 JS that I have, cache the updated version, and then return the full version 3 to the browser. So you can sort of do whatever delta compression, whatever dictionaries, really whatever you want. And if you find something that ends up working well and everyone adopts it, maybe the browsers will bake it in the code. Do be aware that everything you're running is running in JavaScript, so you still need to provide the libraries and the code that does all of this. But still, as far as really cool things, I think this is probably one of the ones that's going to get the most adoption the earliest, because it's one of the real delivering versioned upgrades of JS libraries for sites is kind of one of the recurring asks, and sort of SDCH is the only way that we've had that does that, but it doesn't do it in a great way. And you also don't need like sort of CDN support or anything else, because it's not, you're just making a request for a patch file. Those patch files can be static and served however you want. This is where things get a little hairier, especially when you're running JavaScript. But it doesn't have to be limited to delta compression, right? You've got a new whiz-bang compression algorithm that works better than gzip. So as far as the networking stack goes, gzip is taken care of for you automatically. So any of your fetch requests will automatically, if the server wants to gzip them, they will get automatically gzipped. So the delta compression patches will be gzipped for you automatically. But if you have sort of the new next-gen whiz-bang, this works so much better for my pages, compression, Brotli, maybe, something like that. Images, I wince a little just because doing image decompression in JavaScript feels like a painful thing to me. But if you have something that compresses your images 3 times as small, maybe it's worth it. And especially as an experimentation, a proof point to prove your implementation and that it really does work well, you can build it in service workers. And you can just request those objects in the fetch to the header, to the servers. Sort of the caveat at the end is the thing, as long as it can be implemented in JavaScript, and these days anything can be implemented in JavaScript using transcoding compilers, but you want to make sure the code that you're sending down to implement this stuff isn't bigger than what you're saving by doing the compression, right? Kind of defeats the point. And it doesn't work on first view, right? So you'd only be able to get these benefits for larger interactions with your pages, not if it's like a news site that someone only ever visits once kind of stuff. Progressive images. If anyone knows me historically, this is near and dear to my heart. I was pushing on progressive images really hard until Radware, yes, Kent, hiding in the corner there, until they said people hate progressive images. But one of the things that I was proposing for a long time was for progressive images, one of the cool things you could theoretically do with HTTP2 is you could send down just the first, the first couple of passes of a progressive image, and then hold off sending the rest of the bytes until a lot of the other page is loaded, and then send down the rest. Because usually with progressive JPEGs, once you get around 50% of the bytes of the image, it's almost visually indistinguishable from the final image. So you could literally save half of your image bytes while doing the first above the fold view, and then do another pass that just does really fine sharpening details on the images. Well, one of the cool things you can do in service workers is you don't have to depend on servers actually implementing all this complex scheduling logic. You can see JPEG requests come into your service worker, and you can go, okay, that's nice. I'm not going to pass those through. I'm going to send a range request for that image, or if you have a server that can do things more intelligently and knows where the scan boundaries are, and I'm going to say, hey, give me the first up to 50K of that image. And you can, that's an individual separate request that'll complete. You get the first 50K. You'll also get the full image size with the response headers. And you can send a response, you can construct a response to the browser, and you start streaming in that first 50K, but you don't close the response. You keep it open until some point later when you issue another fetch request, a range request that says, hey, give me the rest of the image, and then you finish the stream that you sent to the browser. So you can sort of do your independent scheduling and chunk things as you send them, while on the network they still end up being 2 completely independent range requests. So that's one of the things I want to play with, just because I think it could be really cool. It could also cause all sorts of grief, and you hope that the browser would actually be doing the rendering. Pain point on web page test in particular. So the waterfalls on web page test are all images. Those are intentional because they're really easy to copy and paste. And that's how they end up in slide decks, and it's a lot easier for people to use them, even though they're not as interactive. Image maps, they're so 1980, right? This is a waterfall. It's really compressed down. I think it was Daily Mail, sort of one of our favorite, has 1,000 requests in the page kind of a thing. That waterfall image is 11,000 pixels tall, and it's 40 plus megabytes in RAM just to generate that image on the server. One of the things that you can do with service workers, and this is actually more coming, you could actually, the actual data to generate that waterfall is probably only about 20K worth of data just to describe the requests and the timing. You could pass down JSON response. You can create a canvas in the service worker that is 42 megs on the client, where I don't have to worry about it on my server. And you can draw the canvas, create a PNG from the canvas, and send that PNG as a response to the browser. So as far as the person interacting with the page is concerned, it's still an image, However, it was really an SVG or something on a canvas drawn by the service worker. So you don't have to worry about the, okay, how do I create a data URI version of this SVG from the page, because the page sees it as an actual image. So in the grand scheme of what you tell the browser doesn't actually need to be what you do on the network side. That's sort of the theme of everything that, yeah, I think, okay, yeah, that's the continuation of the how you would do it. So there was a question at some point earlier, can you inspect the failures at the service worker and use it for logging? Yes, another awesome use case. You can just pass all your requests through and passively observe the timings as well as the failure and success rates of them. One of the things that this gives you visibility into that you don't see with resource timing is you see failures, right? You can see things that don't actually complete, or you can see requests that are in flight that never finish. And you can send information about those back up to the server. I mean, there are standards, network error logging, and some other stuff that's working on browser standard ways to implement this. But you could implement your own version of, say, for all of the HTML pages, I want to inspect and report on errors where it takes more than 3 seconds, or the user abandoned and the request never completed, and stuff like that. And there's more. So service workers are sort of a background toehold that gives you access to other capabilities that the browsers are working on delivering. Push notifications in Android. Those are live in Chrome 42, I believe, stable, where you can do native Android notifications from your web page. I think there are a couple of companies that are just rolling out support for it now. So you can do background notifications. They click on it and they go to the page that was referenced. All that requires service workers to work. Background sync for doing offline synchronization of resources. You can hack it together right now with the cache API, but there's a more structured way for doing it coming so that it does it in idle periods, not while on battery, and sort of some of that stuff for you. Geofencing. I think that's just an idea right now, but I think that's something Alex Russell. So the slightly off GitHub page is Alex Russell's page. But one of the things they're exploring is adding geofencing support for background for web apps. So a lot of the appy stuff that native apps could do are coming to the web platform by way of service workers as well. So one way or another, become familiar with them, even if you don't do cool hacks with them, because you're probably going to start using them for various different things. Mentioned before, it's in Chrome Stable now. It's actually been in Chrome Stable for a little bit. Canary tends to have the more stable implementation of service workers, which is kind of backwards. But definitely crbug.com, provide feedback to the team if you see any issues. That's one of the things we see a lot. The developers working on stuff will generally drive a lot of the feedback and maybe some internal dev teams, but you guys are the actual users, and value from developers providing feedback is much higher than our assumptions about how people are going to use them. So weigh in, please. Your input is very valued by the team. And Firefox, it's in nightly right now. It's not in the stable release for Firefox, but it's coming. And they're also composable. So service workers, they have the ES6 import scripts, so you can basically do includes of other JS. The main JS for the service worker needs to be served from the same scope and domain that it's enclosing. However, it can import JS from anywhere. So this is really begging for someone to build the jQuery or jQuery UI of service workers that provides a framework for things to be able to plug into a pipeline in a stable way. Because if you're doing like delta compression and custom scheduling and custom encoding, you want to make sure those are all scheduled in a sane order. And that's sort of begging for a library of things. So someone creates the framework and someone else creates the VC diff version of the module that plugs in. And then someone that wants to implement service workers on their page can just do import scripts, pipeline, import scripts, vcdiff, import scripts, and then just compose together all of the things that they care about using. And this is sort of my call to action, because I'm pretty sure it's going to be one of you guys in this room that writes one of those frameworks. First one to market wins. And I think that's largely it, so thank you.